In this video, we're going to investigate why the Pythagorean theorem works. So we're going to give a proof of the Pythagorean theorem. Now, if you recall, the Pythagorean theorem says a squared plus b squared is equal to c squared when we have a right triangle with legs of lengths a and b and a hypotenuse of length c. We want to take any right triangle whose legs are a and b and whose hypotenuse is length c, and show that if we have that scenario, then a squared plus b squared is equal to c squared. So we start by assuming we have this right triangle of legs length a and b and hypotenuse of length c. To show the Pythagorean theorem works, I first create a square with side lengths a plus b. Now each side is length a plus b, so I'm going to break it up into a section of length a and a section of length b. Now I can draw a line segment from each of the section breaks. And if I do that, each of those line segments has to be length c because we've just created a right triangle whose legs are length a and b, therefore the hypotenuse has to be length c. So we have this drawing, and because of the nature of the angles here, we've created a square whose side lengths are length c on the inside of the larger square with side lengths of a plus b. Now we calculate the area of the square in two different ways. The first way is our standard way, which is area of a square is side times side, or side squared. Since the side of the square is length a plus b, the total area is a plus b quantity squared, which multiplies out to a squared plus 2ab plus b squared. The second way to calculate the area is to take and add up the four triangles and add up the square. Each of these triangles is a right triangle with base of b and height of a, or base of a and height of b, but they all have the same area, which is 1/2 a times b. If I multiply that by 4, because there's 4 of them, and then add c squared, because the area of the inside square is c squared, I get the total area is c squared plus 2ab. Because the areas are equal, they're the same exact object, just areas calculated in two different ways, I can set those areas equal. And I'd get a squared plus 2ab plus b squared is equal to 2ab plus c squared. Subtracting 2ab from both sides gives me a squared plus b squared is equal to c squared. And that could happen for any right triangle labeled in this way. So now we've established the Pythagorean theorem. For any right triangle with legs a and b and hypotenuse of c, we have a squared plus b squared is equal to c squared. And now we have shown how to establish the Pythagorean theorem.